So this presentation is a tutorial, the training to upstream patches. That's the first part. There's the second part done by Matthew, just done right after this one. So we talk in the previous presentation, we talk about the open source, the open source philosophy, what is it, and so on. So that was touching in general all the open source projects. This presentation is focused on upstreaming, but for the Linux kernel, and I believe that's almost people here is interested in upstreaming Linux kernel code. So we will explain what means upstreaming, what is the meaning of upstreaming patches. We'll explain also the Linux kernel development cycle. Then we explain how is organized the Linux kernel code, because there is a huge number of files and subsystems. We will explain the contribution and then write one patch, then several patches, and concluding and introducing the second part of the upstreaming. So what means upstreaming? So the term of upstreaming is you bring your changes inside the Linux kernel. Why you want to do that? You want to do that in order to prevent to have to port every time your patches on top of the next kernel. Because when you put your changes inside the kernel, the community is in charge of making sure that it's not breaking your code. Until it's not inside, you cannot claim anything. If your code is outside the Linux kernel, it's like it does not exist for the community. But as soon it is merged upstream and it's in the kernel, then it will be maintained by the kernel developer. But also, you have to admit that when you upstream your code, the code does no longer belongs to you. It belongs to the community. So when you do that, you have to be prepared. When you try to upstream your changes, you have to be prepared to restart from scratch. Maybe your approach is not the right one, so community, maintainers, whatever, whoever in the mailing list might ask you to rewrite everything. Then change your approach. And then, if you want to contribute and if you want to bring changes, upstream your changes, also it's a good habit to contribute to the project, to the Linux, and bring changes, not only bring your changes, but also help the community. So it's an exchange of services. You bring things inside the Linux kernel, but also you give help. It's a way to pay people on the community who will take your code and support it later. But when you have to upstream the code, there is no deadline. There is no schedule. Your code can be there for upstreaming as a candidate for upstreaming 1 year. That will depend on your experience on upstreaming code. The more experienced you are, the easier that will be to merge code inside the Linux kernel. Linux is evolution, so it's not a design. That will evolve, and that evolves with small changes. So if you have a big change in the Linux kernel, you have to split that on small changes, providing small feature, and little by little you will make the code to evolve to the big feature you are aiming. Of course, if you have competing approach that sometimes that happen, especially when you are touching generic frameworks and generic code inside the Linux kernel, then these competing patches block the merging process, the upstreaming process. So you have to find a consensus. And that will be the best solution. Usually when there are competing patches, so that means patches bringing the same functionality, but in a different way. Usually the consensus brings that there is the best part of both of them at the end. So if you have competing patches, you have to collaborate in order to have something different, but bringing your functionality and the functionality of the competing patch. So you reach a consensus, and when you reach a consensus, then you have a good chance that your patches will be merged upstream. So the Linux kernel has one rule. We don't want regression. That's what I said right on the slide before. If you push changes, upstream your patches in the kernel, then the community won't break your code. You will take care of not breaking your code. So it's a good, it's a way to know that your code will be evolving and following the Linux changes. Also, because you pass through the review process, you send patches on the mailing list, people will see your changes, they will review your code. The more you have people reviewing your code, the more you have chances to catch at the earlier stage your bugs. So the result is you have a better code quality. Also, the Linux kernel is a very complex. So there are a lot of lines of code. I think it's more than 10 million lines of code. There is a lot of history behind that, million and million and million of changes. And you might not know some subtleties inside the code. By providing your patches, upstreaming your patches, maintainers and people of the community might give you indication about your code to give maybe a direction or simply new API or new subsystem implementing what you already implemented. Maybe what you implemented is already implemented inside the kernel and you don't know that. But the maintainer will tell you that, so that can reduce the code size for you, which is good. And of course, that would you stop porting your code at every kernel release, which is expensive in terms of time and in terms of money, because validating and backporting is potentially introducing a lot of bugs. So the Linux kernel development cycle, we have iterative release candidates. They are all called with the version number, release candidate something. And usually it's every Sunday we have a new release candidate. It begins from RC1 and then usually to RC8, RC7, it depends. It depends on the stability. This phase of RC is a phase of stabilization of the Linux kernel. Only fixes are taken inside. Then, when RC8 is finished, we consider that the kernel is stable enough, we don't spot any more obvious bugs, then the version is released. After that, we have a quiescent period of 2 weeks where all the different maintainers, I will explain that after on the other side of the slides. The different maintainer will merge their tree together, all the changes, into a single one, the Linux tree. And after that, then we have the new version preparing, and we have the RC1, and so on. So that we see that usually So it's always in movement, always in movement. Every week we have a release candidate reaching RC8 or C7. We have 2 weeks of merge window, and then RC1, RC2, and so on. That brings us to a new release more or less every 3 months. We have a new kernel release. So in this time frame, when do you send the patches? Actually, you can send the patches more or less when you want. That's today what's happening. You won't see your patches landing in the next kernel version, but maybe kernel version plus 1 or 2. When you send fixes, you can send the fixes at any time. It will be taken automatically. So the merge window, so the moment when all the changes of everybody are merged together into a single tree, takes 2 weeks. So when do you know the merge window is happening? So when the merge window is happening, that means all the maintainers, all the people taking care of different subsystems are very busy by merging their trees. So usually they are not very responsive at this moment when you send patches. So it's 2 weeks where they are not very responsive. So when you know there is a merge window, is when you have the release number here. Right after RC8, you have V10, for example here, then the merge window begins at this point. So when do you know the merge window is finished? The merge window is finished when release candidate number 1 is out. How do you know the kernel version when they are delivered? You have the website kernel.org. You can poll this website every Sunday, for example, or you can use RSS feed and get notified by message directly on your phone or on your laptop on the mailer. So it's quite easy to track the different versions. We have the Linux Next. The Linux Next is the image of the next Linux version. It's not the official version. It's the result of the merge ahead of the schedule of all the branches, development branches we have around about the Linux kernel. So with this, when you use this tree, you usually already solve the issue, the merge issue you can have, and also that helps to catch the bugs at very early stage. So before the merge window happens, we usually have already the fix for the bug. So how can you start contributing? So there are you should do that incrementally because you need experience in upstreaming. So the first steps are you begin by code review. The code review, you will be receiving patches by email on the mailing list, and then you can review the different cleanups. You can send trivial fixes. You can see if you see a potential issue. For example, I don't know, you think that there is a situation in the code maybe where you can have an initialized variable or whatever. You can take the Linux Next also, compile it, do cross-compile, catch that happens. There are a lot of error of cross-compiling, so it's a good way to begin contributing, create cross-compilation. Use unusual compilation options like header check or sparse. You can also communicate. So you go in the mailing list, you review the patches of the others, you can answer questions if you know the answer. You can boot the Linux next, and you can also go to the Bugzilla, bugzilla.kernel.org, look if there is some bugs. If there are some bugs, you can fix there, and so on. So you have a plethora of possibility. You have a lot of possibility to contribute and begin by training yourself by doing simple things in the contribution. So when you are working as assignee in Linaro, usually when you work in the kernel, you touch this directory. The driver directory is the most impacted one, and then we have the Arch directory, and then kernel, and the other one there are just, well, it's a very small ratio. But usually it's driver and Arch which is impacted. So the Linux code is very complex. There are more than 40,000 files inside the tree. And all these files are organized into subsystems. So in this subsystem, we find POSIX implementation, all the architecture-specific code, the different frameworks for the power, for the file system, and so on. We have the driver, we have the network stack, which is very big. The network stack is more or less 60% of the code in terms of the size in the Linux kernel. It's a very big part. So here we have the topmost directory here and subdirectory. So we have the driver. In there we have all the driver related code. Then we have the Arch directory with the different architecture there and the architecture specific code inside. For example, memory management. We have script and tools. So that's all the tools that helps you to develop, debug, test. We have library, which is not really kernel dependent, but it's a set of simple function we are used to in user space, implemented for the kernel space, like printk. And then we have the generic framework with the kernel, inter-process communication, network, memory management, block, file system, and so on. Yep, just skipping that. Okay. So I've been talking about maintainer before. What is a maintainer? A maintainer is someone who is responsible of one of the subsystems I showed before. For example, we have a maintainer for net, for driver net. We have one maintainer. Then we have one maintainer for USB. Or we have one maintainer for the ARM architecture. For example, for ARM, we have Russell King for this directory subsystem. For the ARM64, we have Catalin Marinas from ARM. For IPC, we have Andrew Morton, Mel Gorman. So everyone, it's different people, is taking care of the subsystem. And the bigger is the subsystem, the more you have subsystem under and more maintainers under. So it's like a tree. And the maintainers are in the node of this tree. So the maintainer is the gatekeeper. Is the gatekeeper, so when you submit your changes, if the changes touches one subsystem, you have to send the patches to this maintainer. he will check that the code complies with a set of rules, codic style, consistency, the code is okay, it's not controversial on the community, and also if it's technically relevant. He has a very big responsibility because it's the guy who makes sure that the code is evolving in the right direction. So each directory falls under the umbrella of a maintainer, and each maintainer has its own tree. So Git, the Git tree is a source revision system designed to work in a distributed way. That means that everyone having history can, by splitting the different subsystems, we don't have overlap, and then it's very easy to merge this tree without conflict. So I was talking before the merge window, so that's this part. So each maintainer is sending the information to the topmost maintainer saying, okay, my tree is ready, you can pull all the changes into your tree. And then the topmost maintainer pull its tree and send another pull request, that's the call, it's called a pull request, send another pull request to its topmost maintainer. And that reach Linus, which is on top of the tree, and taking all the tree of its sub-maintainers. So it goes from the bottom to the top. All the maintainers are stored in a file, so the information about who is taking care of what is stored in a file called maintainers. So this is an example of the merge process. We have different trees. Here we have the Linus Torvald tree, the topmost tree. Then we have here one part which is IPv4. So it's this tree plus a set of changes inside this subsystem. Then we have the tip tree. So it's this tree and all these changes, all these subsystems are changed. Under we have another changes in driver clock source, driver ARC chip. So now we begin the process of the merge. First, before the merge, we have the different patches proposed and taken by the maintainer. So the maintainer takes the patches and merge that in their tree. So we have here the tree diverge inside these subdirectories. So we have a delta here, which is tip, this one, plus a change in the ARC chip. And this one, which is this tree, plus a change in the clock source tree directory. Then we have the pull request. So this tree is merged in this tree. Okay, so that just bring all the change in this directory inside this directory, and all the change in the clock source directory in the upper tree, the driver clock source directory. So it results that the V10 tip contains changes of the different sub-maintainer. At this point, they reflect the topmost maintainer. Then, next step, all the sub-maintainer or the topmost maintainer, which is Linus Torvald, send their pull request to Linus Torvald. All the three are merged, and then at the end, it results that all the trees are the exact reflect of the Linus tree. And that's the end of the release process. So when all the three were merged, we have the release candidate, which is delivered on the kernel website, and it's a new iteration, a new version for the kernel. So we see that thanks to the mechanism of merge, and by splitting the big tree, Linux tree, into smaller tree owned by different people, every people is responsible of a subsystem, and when we begin the merge, we don't have any conflict. We bring changes from the bottom to the top without conflict. Well, without conflict. We can have some conflict, but are very trivial usually. So the communication are all done through the mailing list. So for the mailing list, for Linaro, which is important, is LKML and LAKML, which is the Linux ARM kernel mailing list. And then you have to use what the content of the maintainers file, because the maintainers file contains the mailing list and the email of the maintainer. And you have to rely on this information when you send your changes to put in copy this mailing list, LKML or LAKML, and then the mailing list put in the maintainer file and the subsystem maintainer. You have a list of all the mailing lists for the kernel at this place, in the third line here. And when you are discussing, so replying to comments and to questions, never do point-to-point. Never answer to the guy itself. Always reply to everyone. It's part of the discussion, it's part of the review process. You don't go to private discussion. Always keep that public. And there are the open source events where you can, sometimes it's difficult to discuss complex changes inside the kernel just by email and just by sending patches. So events like Linux Plumbers or ELC or Linaro Connect are a good place to discuss face-to-face with maintainers and with other people presenting and explain what is more difficult to explain via email. So when you have a big change, a big feature you want to submit, it's usually the best thing is first you propose your change you propose a presentation about your change, ELC or Plumbers or Linaro Connect, and then that raises some discussion, and from there you can then begin to discuss on the mailing list, and people are already aware of what you are talking about, and will be willing to discuss about that more easily. So how to begin? Where to begin when you want to contribute? So the first thing is just send very simple contribution. So that allows you to train by sending patches, by sending patch to the right person, to set your tools correctly, don't fall in the pitfall about copy, mailing list, and so on. And so you can just look at the code, do that code listing, and you review the code. You see what if you see some typo or I don't know, something very simple. So you can send this kind of fixes when they are very trivial to trivial@kernel.org. So you don't have to send that to a maintainer and so on and get in discussion. If you have simple things like typo or something like that, you send that to trivial. But don't flood, don't be sending 100 patches fixing, I don't know, a typo. Otherwise it can be very annoying at the end. Another way to do that is to use the check patch. So we saw before we have a directory called scripts tools. Inside this directory we have a script called check patch. And check patch allows you to not only check a patch but also check a file and make sure that it complies with the codec style rules. So you can run this script, for example, in a big directory on all the files and see if you have warning or errors about the coding style rules, fix them, and then send the fixes. It's another way to contribute without changing the functional aspect of the code, which can be more difficult. So take care that sometimes the check patch script returns false positive. So don't be sending patches for false positive, because that's, well, does not make sense. When you send a patch, always it must be a rule. You compile and you boot at a minimum, always. Even if it's a typo, you don't know. Maybe you press a key somewhere and you put a semicolon somewhere in the code and you broke the compilation. So always compile, make sure that there is nothing wrong, and boot it. Then, when you write the patch, you have to put a description of the patch inside. So just write a nice description, why you are doing this change, what you find. And then it can be, first you begin the description by a simple line, one line, giving a description, just one line, and then a block giving a more detailed description. Of course, when it is a typo, you don't have to write a book. Just saying it's a typo, it's enough. But if you do a change more, I don't know, maybe you spot something subtle, you have to, this subtlety must be explained clearly in the change log. Why do you have to write one simple sentence? Is because this simple sentence becomes the subject of the email when you send the patch. So in this sentence, it should be very short, giving just what you are fixing. Before sending the contribution, you have to read the developer certificate of origin. It's very important. It's very important. It's a legal aspect. You have to fully understand what is saying there, because when you send a patch outside for contribution for the kernel, you are legally responsible of what you are sending. That means if you send the code of your company with your mail, you are legally responsible. So you have to take care of that, because here in this DCO, it tells that when you sign off, and you have to sign off, the sign off is just you write this line, sign off by with your name and your email address. When you send a patch with your sign off, you certify that the code you are sending is open source code, you are allowed to send this code, and so on, blah, 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 blah. And it means that you are responsible that this code is open source. So when you send trivial changes, don't send thousands of trivial changes, because it could be annoying for the guy who is taking care of taking these patches. It's not very important. If you send 3, it's all right. But what is very important is to read the developer certificate of origin and understand it. You have to understand it. If you don't understand it, send me an email and I will be happy to explain you and elaborate if there are some points which are unclear. If I'm not able to answer, I will just let you ask a lawyer. But if otherwise, I can answer you.
So, quick question: trivial changes. I would guess that a comment is a trivial change.
Yes.
What would constitute a trivial change? Is there such a thing as a trivial code change?
For a comment?
No. Is there? You said you have this thing called trivial changes.
Yeah.
Okay. I assume a comment change would be trivial.
Yes.
But. Yeah, but the microphone's not working. But anyways, for code, is there such a thing as a trivial change?
Yes, you can be changing, for example, a variable name because it's unclear what is the meaning of a variable. For example, A. You have a variable A. You say no, it's not A. It's just average.
Fair enough. Then do you have guidelines? What's trivial and what's non-trivial?
Yes, it's described in the documentation. In the directory documentation, there is. Yes, so in the documentation, you have the description of trivial, what enters in this category. So I think I don't remember it's trivial or maybe it's submitting, maybe here, or submitting patches. But there is a description of what is trivial, yeah, somewhere in there is a use documentation there. Okay, so these are examples of simple contribution. So here, we have a contribution. So this is already merged. So this is why we don't have that in an email, but it's more or less the format of your email. What you have here is the author. So the guy who sent the patch, not the send the patch, but where in the patch is right author name. Usually is the same guy who sent the patch. So here you have the author of the patch, and here we have this first sentence, which is usually it results in the subject of the email containing the patch, and then you have here a description. So this is coming from a check patch. So he catch some error here and warning, and the fix. So that in the description it says, okay, fix the warnings and fix the error catch by check patch, and it gives the list of warning. And the trivial patch, it does not change anything. It just replaces spaces here, spaces by tabulation. There is no functional changes. It's trivial. The coding style say that you don't use space to do tabulation, to do indentation. That's what the coding style documentation say. Someone sent the patch with space instead of tabulation. It passed through the review process because this kind of thing is difficult to see by the review process. It gets inside, and someone to the script, check patch, and then run it, and check patch say, hey, you have this line contains space instead of tabulation. So the patch there is no functional changes, it just change space by tabulation. That's a fix. That's a contribution. It's very easy. Another contribution. Does not work anymore. Tiny URL is great, but sometimes. Another contribution, for example, this function add this parameter in CPU, but it's not used inside. So the contribution just remove the CPU parameter. We don't use it. So it's a cleanup, and that's this kind of patches is well received from the community because it's cleanups and it makes just the code nicer. So when we saw that we have one simple patch, single patch sent, trivial. It's easy to send, and it's good to send trivial patches as a first step to begin contributing and train yourself to the review process and the open source contribution. But then, when you have more complex contribution, you have to apply to be more put more rigor in what you are doing, because you can break the kernel in this case. So, in order to provide complex contribution, don't do that in a single patch. Split the patch in simple incremental changes where the maintainer and people reviewing the patches can see how you go from point A to point B easily. So you bring the patches, the changes step by step. Step by step means patch per patch. So there are incremental changes. And as there are several patches, it's very important that you make sure that it's JIT-bisect safe. What that means? That means that for every patch, the kernel must compile and boot. There is no regression. Why? Because there is a mechanism, because of the number of contributions the kernel, there is a mechanism which is the bisecting. This bisecting allows to narrow down an issue by splitting in two the different stack of changes. Let's pick an example. If we have 1024 changes, and then in this stack of changes there is one introducing a bug, and you want to find out which change brought this bug inside the kernel. Then you use a mechanism which is called the JIT-bisect. Then by JIT-bisecting you say, okay, my kernel does not work, so the JIT-bisecting will split this 1000 in two, so you have 500. You test. You say it's okay or it's not okay. It's not okay, so that means the bug is introduced before, so it's split in two, so you have 256. It's okay? No, still not okay. Okay, so then we split into 128. And so that means in log the two, we can narrow down a patch introducing a regression inside the kernel. But this mechanism can only work if the different patches are JIT-bisect safe. That means they compile independently and they boot the kernel. If you have 10 patches, you apply first patch, compile, boot. Then apply second patch, compile, boot. Apply third patch, compile, boot. That must be JIT-bisect safe. If you don't do that, then you break this JIT-bisect capability of the kernel. And then that will upset a lot the people of the community, because they will want to narrow down, try to find out which commit introduce a regression. Your patch set will prevent this JIT-bisecting and make the life of the guy who is debugging the kernel a nightmare. So when you are preparing to send a complex contribution, it's not necessarily you don't have to send everything in one time. You can split that in smaller series, 3 patches, 4 patches, by cleaning up around the subsystem, preparing, making the code nicer, and set the same for the next changes. So, for that I will give you an example with the loopback. The loopback is the network device It was coded inside the kernel. It was a big static variable used around all the kernel because there were just one instance of this network device. But then, when the network namespaces were introduced, we wanted to create multiple network stack. And because of that, we had to have several loopbacks. And in this case, we have to dynamically allocate the loopback. So we show you how in 2-patch this mechanism has been provided without breaking anything in a code which was designed since 1 decade. So that's the impact. In 1 patch, we do one single change, one change. But we impact a lot of files. This change is just we keep a single instance, but we use a pointer. We don't no longer have a static variable, we have a pointer. And then in all the code, we no longer use the address to the static variable, but we use the pointer. We didn't change any functional. We didn't change the functional of the code. There is a big impact, and we just change a static variable to be a pointer, and all the code around is using, for example here, is no longer using loopback def, but a pointer. Then, thanks to that, as we don't have anymore the code all around the kernel referencing a static variable but a pointer, we then in this patch replace the pointer here by a dynamic allocation. And thanks to that, we are able to create multiple instances of the loopback, and that's the first brick of the network namespaces in 2 patches. So the patch is big itself, but it's just one change. Change a pointer, a static variable addressed to a pointer. That's just, and we in 1 patch we change a lot of files, and it's a single change. Okay, so I want, if you are interested to see example of more changes inside the code and see series of patches, you have the reference here of the different patches that gives you a good example of how complex contributions are done. So before going to Upstreaming 201, you have to make sure that you have the right mindset. First of all, be polite on the mailing list. Be patient. You send patches, maybe the guy who is receiving the patches don't have the time to review them immediately. Maybe can take 1 week or 10 days. Maybe more, sometimes more. Be patient. Be humble. Your code might be not the best one. Maybe the comments and the criticisms of the guy who is commenting your code and reviewing your code makes sense. Maybe your code can be simplified much more. Always keep in mind that you have people in front of you who might be much more used to code inside the kernel. Be factual. Don't take things for you. It's about your code. If there are some criticism, some comments on your code, just say factual. If you disagree, it's okay. Take your code, do measurement, show why your code is good, why you think your code is good, what it provides, stick to technical reasons, and that's all. But always take into account the comments. Always, when you have people sending comments to your code, take into account the comments. Answer. You have the right to disagree. You have the right. You just have to explain why you disagree. But you have to answer the people commenting your code. Always. You take into account the comments. So when you see someone sending patches providing a feature, don't send competing patches. Don't send your patches. Maybe review the patches, and if you see something is missing, or if you think that it can fulfill your need, you don't need to send a competing patches. When you send the competing patches, you prevent this feature to enter the kernel. Because when there is competition, there is no consensus. And when there is no consensus, your patch cannot get merged. Because the maintainer does not take patches with controversial competing patches and so on. So don't send competing patches. Take the time and read the documentation you have in the documentation process directory. The important things are the coding style rules, the developer certificate of origin. I already mentioned that. It's important you understand. You have just to understand one time. It's not, you don't have to read it every time. But you have to understand the developer certificate of origin. You are legally responsible of the code you send outside. And also, you have a website with a lot of documentation for kernel newbies, and it's in this website called kernelnewbies.org, and you will find a lot of material there which can help you to jump into the different subsystems. There are explanation, details, a pointer to documentation. It's very complete. So, don't be scared when you want to send patches. Criticism on your patch is good. That means it raises interest. That means people is looking at your patches. The worst thing is there is no answer on your patches. That's the worst thing. Be altruist, polite, patient, and humble. When sometimes, you know, that's the problem of the email. When you receive the email, usually is not, you receive the email depending on your mindset. If you are angry or you are tired, you can take a message in a different way if you were happy. So make sure that you don't react on a patch. Just keep calm, stick to technical reasons, and that's just the line for you. One way is also to not be afraid, is to increase your self-confidence on what you are able to do, what you are capable to do by reading the documentation. Read the documentation. And before sending things for you, send things for the other. Clean up, answer questions. So be altruist. If you are altruist in the community, then it's that we encourage yourself to be part of the community, and that will increase your self-confidence. Okay, do you have questions? No?
I think so. I know this was focused on the kernel side. How much variability is there across projects? Or they sort of follow the same concepts? So if I went, like, for example, to the Zephyr project.
I think it's more or less the same. It depends on. So on the first presentation, I showed there are two development model, the cathedral model, and the bazaar model. And the bazaar model is when you have all people, when you have patches going around in the mailing list, so you can see the changes in real time, more or less. You can review the patches and so on. So that's more or less, I think is the standard now. Some projects are working as a cathedral. There are a few ones. For example, in Android, we have some parts which are more cathedral than anything else. But the standard is usually bazaar, so that means review process, sending patches. So I think Zephyr, I don't know because I never contribute, but from my experience for the different projects I see, it's the same. So we send patches on mailing list and they are taken. The only thing is on Linux there are a lot of people on the mailing list. So there are a lot of traffic, answers, and can be lost. In smaller projects, you have less messages, but also less review. So that's the difference.
Yes, Zephyr has the same process.
It has the same process.
They don't use the mailing list to submit patches, but directly via GitHub.
Okay. More question? Yes?
What if I want to send a patch and it was in the host table, for example, 3.18, and well, the community will merge my new feature into a newer version of a kernel?
So you mean if you want to merge a new feature inside of 3.18, for example?
Yes.
That you can't. You can't.
I can merge I can send the patch to.
For a new feature in a 3.18, no.
What about the new driver?
No, you can't. For the mainline, no. What you have is they only accept fixes. That's all. And new feature is for the next version, always. So if it's Android, for example, in Android is different. In Android, because there are LTS and version of kernel, so usually in Android they can take, but in the Linux kernel, no. No more question? Okay, thank you.